Okay, ladies and gents, so what we're going to do now is we're going to do a revision video based just on logs. So these are the past exam questions over the past however many papers. And now I know people will struggle with this, so we're going to go through how to do it and all the steps that you need to go through, and you'll start to see how similar the questions are. So we've done this one relatively recently, but it bears repeating. So we've got y equaling 3x squared, and we've got to show that log to the base 3 of y equals that. So they've started off with this, and then they've brought logs into it. So the way they've done that is just taken logs of both sides, and they've taken log to the base 3 of both sides. So that's what we do. Log to the base 3 of y equals log to the base 3 of 3x squared. Now our left-hand side looks like this left-hand side. However, this here doesn't look like this side here. And in the question we can see that this here has got two parts to it. And here we've only got one thing on the left-hand side. Now one of the log laws is where we bring this power down, but we can't do it at the moment. And the reason that we can't do it is because the whole thing here isn't to the power of 2. It's only the x that's being raised to the power of 2. So because we've only got 3x squared, we're going to need to split this up. Now we should know that log 4 plus log 6, if you've got two logs where they're being added together and it's got the same base, then you can actually say log of 4 times 6. That's another log law. So if we've got this here, we're going to do the reverse. So we've got log to the base 3 of y equals log to the base 3 of 3 plus log to the base 3 of x squared. Now, the whole thing with logs, log to the base 3 of 3, I want to know what that equals. So this 3 to the power of this, whatever this answer is here, equals this thing. So 3 to the power of something equals this thing. So 3 to the power of 1 equals 3. So log to the base 3 of 3 is 1. So we can replace this equals 1. And then we can do what we said earlier about bringing this power down, because it's only the x that's being raised to the power. So that's going to be 2 log to the base 3 of x, and that equals log to the base 3 of y. And then that gives us what we have here. It says, hence or otherwise, solve this equation here. So we now know that this thing here equals log to the base 3 of y. So we've got log to the base 3 of y equals log to the base 3 of 28x minus 9. So if log to the base 3 of y equals log to the base 3 of this, then y, whatever's in this bracket, must equal whatever's in this bracket. So y must equal 28x minus 9. And we also know that y equals 3x squared. So if solving those simultaneously, we've got 3x squared equals 28x minus 9. And now it's starting to look like a quadratic. We can't divide through by 3 because 3 doesn't go into 28. But as with any quadratic, we get everything over to one side. So it's going to be 3x squared minus 28x plus 9 equals 0. We then factorise that, so 3x and x, and 9 and 1, and we get that there. So we've got to solve that. So we've got x equals a third for this bracket, and we've got x equals 9 for that bracket. Okay, let's go on to the next question. Ignore the fact that although it's the second question, it says question 3, because I've had to delete some of the questions because they weren't really log questions. So the next thing we're going to do is find the values of x such that that equals that. So what we've got here is we've got a 2 in front of the log to the base 3 of x, so we can raise that power up. So we get log to the base 3 of x squared minus log to the base 3 of x minus 2. So we've got a log here, take away another log. So because we've got a minus there, what we're going to do is we're going to divide the logs. So it's going to be log to the base 3 of x squared minus x minus 2. So notice it's not log divided by log, it's log to the base 3 of this divided by this, and that equals 2. Now again, the first lesson that we ever did with logs, this means that 3 to the power of 2 equals whatever this thing is. So 3 to the power of 2 equals x squared over x minus 2. So 3 to the power of 2 is 9. So 9 equals x squared over x minus 2. We're then going to bring this up to the other side. So we've got x squared equals 9 lots of x minus 2. And now it's starting to look like a quadratic again. So we've got x squared minus 9x that equals 9x minus 18. So x squared minus 9x plus 18 equals 0. X minus 6, x minus 3 equals 0. So x equals 6 and x equals 3. So the key thing here, because when you get to this point here, it's just a matter of being able to solve a quadratic, which is sort of very similar to a lot of the C1 and even the GCSE work that you've been doing. However, it's to be able to spot that here we've got a log take away another log, but we can't do anything until we've just got a log take away something else, because initially we've got 2 lots of log 3x, so we've got to deal with this 2 to start off with. So we get rid of the 2 and raise to the power, and then we've got a log take away a log, so we just divide the subjects there. Okay, next question. So find given your answer 3 significant figures where appropriate the value of x for which 5 to the power of x equals 10. Now some people's calculators do this, but if yours doesn't, we're going to take log to the base 10 of 5 to the power of x equals log to the base 10 of 10. And then what we can do is we can bring this x down, just like we did in the last question, except the opposite. We brought it up. So we get x log to the base 10 of 5 equals log to the base 10 of 10. Log to the base 10 of 10, of course, is just 1. And then what we do is we divide by this log to the base 10 of 5. So it's going to be log to the base 10 of 10 divided by log to the base 10 of 5. And then put that into your calculator and you'll get to whatever answer you get. I just want to point out though that here we're actually dividing the logs, so we've got to write it like this. That won't be the same as log to the base 10 of 2. The answer is actually 1.431. Well, it's it. Answer 3 significant figures, so 1.43. Yeah, here's log divided by another log. So we've got to make sure that we do that. We don't just, it's not the same as take away a log. Okay, so 1.43 is that answer. We're now going to do the next one. So the whole thing with logs is that the base to the power of this equals this thing. Okay, all that is just practice over and over again. So 3 to the power of minus 1 equals x minus 2. So 3 to the power of minus 1 is 1 over 3 to the power of 1. That is x minus 2. So we're going to have 1/3 equals x minus 2. So x equal, if you add 2, 2 and 1/3. So there's 3 significant figures, so that's going to be x equals 2.33. Again, at any point, feel free to pause the video, come in and ask questions afterwards. But I know that a lot of people struggle with this, so it's worth doing just a load of these revision questions. If you can walk into your exam knowing that you've got a topic pretty much nailed, that should start to fill you with loads and loads of confidence. Okay, next one. We can't subtract these logs at the moment, again, because it's not a log take away another log. We've got a 2 in front of it. So we've got to deal with that 2 by raising it to the power. So it's going to be log to the base 5 of 4 minus x. minus log to the base 5 of x squared equals 1. So we've brought the 2 up, and that's going to be enough to give us 1 mark. We've then got a log take away a log, so we're going to divide the subject. So it's going to be log to the base 5 of 4 minus x divided by x squared. That equals 1. And then again, the base to the power of the answer equals this thing here. So it's going to be 5 to the power of 1 equals 4 minus x over x squared. 5 to the power of 1 is just 5. We're then going to bring this x squared up. So we get 5x squared equals 4 minus x. We've then got x squared, we've got x, and we've got numbers, so we're going to make it quadratic. So 5x squared plus x minus 4 equals 0. So it's going to be 5x and x. And we've got 4 and 1. And we get that. So we've got x equals minus 1. And we've got x equals 4/5. However, it says find the value of x. It does say values, and we've got 2 values down here. And it also tells you that x has got to be between 0 and 4. So this one is not inclusive. This is the one that we're looking for. So x equals 4/5. Just be careful of that, because it's easy to lose that last mark unless you're being vigilant. Okay, question 6. Again, I'm going to repeat myself so much during this video, but that's okay. As long as you start to sort of take in a load of the log laws, that's all that you're meant to be doing with this. However, this one's slightly different. So we've got 7 to the power of 2x minus 4 lots of 7 to the power of x plus 3 equals 0. Now, it almost looks like a quadratic, and that's because it is. So this 7 to the power of 2x, one of the indices laws that you should know, 7 to the power of 2x, we can actually write that as 7 to the power of x to the power of 2. Because if you've got powers raised to powers, you just multiply them together. So we can actually write this out as 7 to the power of x squared minus 4 lots of 7 to the power of x plus 3. And then we just solve it like a quadratic. If you want to, you can actually say 7 to the power of x equals, say, a. So you've got a squared minus 4a plus 3 equals 0. Or if you have just factorising, but instead of the a, you write 7 to the power of x, that's also fine. But if you're not, you can factorise and get a and a minus 3 minus 1. So you've got a equals 3 and a equals 1. Oh, sorry, I've done part B first. I'll go back and do part A in a second. Remember, it's not a, though, that you're looking for. A is 7 to the power of x. So you've got 7 to the power of x equals 3, and you've got 7 to the power of x equals 1. Now, this bottom one is dead easy, because anything to the power of 0 is 1, so x equals 0. This one is slightly different, so you've got to take logs of both sides. So you do log 7 to the power of x equals log 3. You then bring the x down, so it's going to be x log 7 equals log 3. X equals log 3 divided by log 7, which equals 0.565, or it says 2 decimal places, so 0.57. Okay, sketch a graph of y equals 7 to the power of x. So anything to the power of x looks like that there. Now if it's 7 to the power of x, we're going to start off with this one here, this point here. And anything to the power of 0 is going to be 1. So we're going to go through at 1. And this could be 2 to the power of x, it could be 3 to the power of x. The thing that makes it trickier, or the thing that makes it different, is that if it's a higher number, if you imagined 1 there, 2 to the power of 1 would be 2. 7 to the power of 1 would be 7. So the only difference is that it makes it a steeper graph. And also, because it goes up steeper, it comes down steeper, so it's going to go across like that. But as long as your graph looks like that, you're going to end up with the correct marks. Mr. O'Rourke has come around just to check this out. Okay, so the next one that we're going to be looking at is find a positive value of x such that something to the power of, so again, it's just knowing that this is something to the power of 2 equals 64. That says a positive value, so obviously minus 8 squared equals 64, but also 8 squared equals 64. Next one, solve for x. So again, we've got one of these questions where you've got to rearrange to get log something equals. So if you bring everything to the left-hand side, you're going to have log to the base 2 of 11 minus 6x minus 2 log to the base 2 of x minus 1 equals 3. So what we're now going to do is we're going to bring this power up, because you can't do a log, you can't divide it because it's not log take away a log, it's log take away 2 logs. We've got to deal with this 2 first. So it's going to be log to the base 2 of 11 minus 6x minus log to the base 2 of x minus 1 power of 2 equals 3. So that's going to be log to the base 2 of 11 minus 6x over x minus 1 squared equals 3. And then we've got log to the base, so I can't really read that, log to the base 2 of that equals 3. So it's going to be 2 to the power of this equals this thing. So that's going to be 2 to the power of 3 equals 11 minus 6x over x minus 1 squared. So let's do x minus 1 squared. So x minus 1 squared. Remember, if you've got a bracket squared, you've got to write the bracket out twice. So x minus 1 times x minus 1. So you're going to have 2 to the power of 3, which is 8, equals 11 minus 6x over x squared minus 2x plus 1. And then going to bring this up. I'm going to multiply it by 8, so it's going to be 8x squared minus 16x plus 8 equals 11 minus 6x. We're going to move everything to the left-hand side. We're going to get 8x squared minus 10x minus 3 equals 0. And once we've got that, we're going to factorize it. So without me having the answer in front of me, I'd imagine it would be 4x and 2x. Yep. And then you've got the 3 and the 1. So you want to make it a minus 12x, so that's going to be 4 times minus 3. And then you want the plus there. So you're going to get x equals minus 1 quarter and x equals 3 over 2. So those are your two solutions. Next question, question 8. So again, it's just a matter of knowing that this is 2 to the power of minus 3 equals y. So y equals 2 to the power of minus 3 is the same as 1 over 2 to the power of 3. So it equals 1/8. The next question, I think the next question is pretty tricky actually. What we're going to do is we're going to bring this up to here. But you've got log to the base 2x times log to the base 2 of x. What we can do is we can say that that makes it, so let's get some room to do this question. So if we bring that up, that's going to be log to the base 2 of 32 plus log to the base 2 of 16 equals log to the base 2 of x squared. Now notice that this one, this is different. Log to the base 2 of x squared, because you times it by itself, that does not equal the same as log to the base 2 of x squared. So we can't bring that 2 down. Because it's not just the x that's being squared, it's the log to the base 2 of x. The whole thing is being squared, so just be careful with that. Now, log to the base, go back to this. Log to the base 2 of 32 means 2 to the power of something is 32. So 2, 4, 6, 8, sorry, 2, 4, 8, 16, 32. That's going to equal 5. Log to the base 2 of 16. 2, 4, 8, 16 is going to be 4. So we've got log to the base 2 of x squared equals 9. So we're then going to square root it. So we've got log to the base 2 of x equals 3, and log to the base 2 of x equals minus 3. Now the giveaway for that is here. It says find the values, so it's more than 1. So we've got, this is 2 to the power of 3 equals x, so that's going to be 2 to the power of 3. This is going to be 2 to the power of minus 3. So it's going to be 8, and it's going to be 1/8, because as we've said before, it's this thing to the power of this thing equals this thing. So we've got our two answers. Okay, so next one. Given that this, so what we've got to do, again, all we've got to do is we've got to rearrange this so that it equals this thing here. So we deal with this 2 by bringing it up to here. We then got a log take away a log. So that's going to be log to the base 3 of x minus 5 squared over 2x minus 13, and that equals 1. So then we've got this whole thing here, and we've got this thing to the power of this thing equals this thing. Again, it's the same thing over and over and over again. So 3 to the power of 1 is 3, and that equals x minus 5 squared. So if we multiply that out, it's going to be x squared minus 10x plus 25. Again, if you're unsure on that, do x minus 5, and then do the smiley face on the brackets. That's going to be over 2x minus 13. We're then going to bring this up to this side. So we're going to get 6x minus 39 equals x squared minus 10x plus 25. We're going to get everything over to the right hand side. So you're going to have x squared minus 16x plus 64, which is exactly what they want us to do there. Then it says hence or otherwise solve. So we know that this can be written as this, so we've just got to solve this thing down here. So x minus 8 times x minus 8, so x equals 8. Next question. Again, exactly the same thing. We can't do the log take away the log because it's not, you've got this 2 here, so we've got to deal with that first. So it's going to be log to the base 2 of x plus 15. We've got to make x plus 15. We've got to bring the 2 up to make it squared, and then we can divide by the x. So we've done 2 sets in 1 there. We've put the 2 up here, and then we've divided, so we've brought that x down underneath. So then 2 to the power of 6 equals this thing. So 2 to the power of 6, 2, 4, 8, 16, 32, 64. So we've got 64 equals x plus 15 squared. So that's going to be x squared plus 30x plus 225 all over x. We're then going to bring that x up, just as we have done numerous times before. So it's going to be 64x equals x squared plus 30x plus 225. So make it equal to 0, x squared minus 34x plus 225. So it's spot on. And then exactly the same as last time, they said solve this equation. So that's the same as that equation. So what we've just showed is that this can also be written as this. So all we've then got to do is we've got to solve it. And generally it will factorize nicely. So if we factorize that, we're going to have an x and we're going to have an x. Now 225, I know that 25 goes in there. So 25 goes in there 9 times. And 25 and 9 makes 34, so they're both going to be negative. So x equals 9 and x equals 25 because it says solve. So therefore you've got to write down the solutions as well. And I'm going to pause now because I'm bored. So I'm doing the same thing over and over again. If you need any more help, come and find me. But other than that, enjoy.